Okay, let's give you guys some more practice. So now I'm going to put you on Neptune. Gravity on Neptune is 11. We're going to fire a cannonball at 60 meters per second at an angle of 32 degrees. There's a mountain 200 meters away. Well, 30 meters is a bit small for a mountain, but let's just say a mountain of 30 meters high. When you fire the cannonball, will it be able to pass the mountain? It could do this, or it could do something like this. So this is all that you're given. Find out if the cannonball is able to pass the mountain. So when you do this, try to find out the location of the maximum height. So the maximum height could be over here, in which case it would do something like this, or the maximum height could be over here, in which case it would do. Well, try and find out the location of the maximum height. That will give you a rough idea of what's going on inside your head. Okay, well, do whatever you want. Find out if the cannonball is able to pass this mountain. So press pause and have a go. Okay, so to do this here, try to try to break this up. Try to break this up into its vertical and horizontal components here. Okay, so this is the vertical component here. Hang on. Yeah, this is the vertical component. Then jump to your velocity time graph. And then the equation of this line here is given by this. If I'm going too fast, then watch some of the earlier videos. Okay. Now at the maximum height, the velocity will be 0. So you put 0 into this v here, so it becomes this, and then work backwards to find out t. Okay. So this is the time it takes to get to its maximum height. So this is the time it takes to get to its maximum height here. So maximum height is here. Now, this is the initial vertical velocity. If you want to know the actual maximum height, it will be the area underneath this graph here. So if you want to work out the area, you would get this times this. So that's what I've done here. Is this times this fraction here, and then cut in half because it's a triangle here, and then cut in half because it's a triangle here. Okay, so this gets multiplied to the top, so it becomes so this thing here. Hang on, this whole thing here. This whole thing here is this thing here, because this bit gets multiplied to the top, and then visualize the divide by 2 as this. So when you've got a fraction, you divide by 2, it gets multiplied to the bottom, so it becomes 22. Okay, and well, anyway, punch this into your calculator, and then this here would represent the maximum height. Okay, so far we know the actual maximum height, and we know the time it takes to get to maximum height. So the maximum height could be here, or it could be over here. What we do know is that the maximum height is 5.95. Okay, and the other thing that we know is the time it takes to get to the maximum height. Well, it takes well, from above, that means somewhere earlier I've worked out the time it takes to get to the maximum height is this. Punch it into your calculator, and then it will give you this. So this represents the time in seconds it takes to get to its maximum height. You see, this diagram is in meters. You see, this thing here is 200 meters. But all we know is that it takes 2.89 seconds to get to its maximum height. But you see, this is in seconds, and this is in meters. So we've got to find out if, well, our maximum height could be before the mountain or it could be after the mountain. We don't know yet. Well, now, but we know this the time it takes to get to the maximum height. So what we do is we imagine you and your dad sitting in the car traveling at this speed for 2.89 seconds. How far would you have traveled in 2.89 seconds? Will you have traveled this far, or will you have traveled this far? Okay, so what you do is you get the horizontal distance of, you get the horizontal speed of the car, and then you times by this time here. That will tell you how far you would have traveled just to get to the maximum height. Okay, so here, get this times this, and then this number here represents the distance now. Okay, so the maximum height is here. We know we know the time. We know it takes 2.89 seconds to get here. But then we just worked out the actual horizontal distance to get to the maximum height, which is 147.05. So this distance is 147.05. You see, the mountain is 200 meters away. So we know our maximum height is before the mountain and not after the mountain. Okay, so so far this is maximum height here. Maximum height. Well, you see, the horizontal distance at the maximum height is 147.05. You see, we still got this gap here. We want to know the height of the cannonball when it's 200 meters away. So now you've got to get this. Take away this. That will give you this distance here. And then remember, you and your dad sitting in a car here, traveling at this speed here. So you've got to get this distance divided by the speed. That will give you the time it takes to get to this mountain. Okay. So get this, take away this. That will give you the distance across here. Okay. So we still got to travel another 52.95 meters. Now get that divided by the speed of the car. That would tell us that, oh, it takes another 1.04 seconds to get from maximum height to the mountain. So it's going to take another 1.04 seconds to get to the mountain. But you see, in 1.04 seconds, how far would the cannonball have fallen? How far has it free fallen? So after the maximum height, it will free fall. But don't forget, it's free falling for 1.04 seconds. Okay, so now imagine you standing on top of the building here. This point here is the maximum height, and the building. Remember, we just worked out that the actual maximum height is 45.95 seconds, and we know it's going to free fall for another 1.04 seconds. So put this into here, and then blah 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 blah. That will give us the distance it has free fall by the time it gets to the mountain. Okay, I know it's a bit complicated, but just listen and follow it through, and then I will give you a chance to look at it again later. So now it has fallen 1.04 here. Okay, so you put that into this formula here. Okay, and then that will give us this here. So this number here represents the distance it has fallen here. Okay, but by the time it gets to the maximum, by the time it gets to the mountain, so this distance here, this here represents the distance that it has fallen by the time it gets to the mountain. Okay, so hang on. Oops. So basically, you would get this. Take what? Remember, this is the maximum height, and by the time it gets to the mountain, it would have free fall for this amount of distance here. So you get this. Take away this, it would be 40. So what that means is that by the time the cannonball has got to the mountain here, it would have free fall by 5.95. That means, well, by the time it gets to the mountain, you see this 40 here represents the distance by the time it gets to the mountain. So well, the mountain is the mountain is 30 meters high. By the time it gets to the mountain, it's 40 meters high. So you see, by the time it gets to the mountain, it's above the actual mountain. So you know it's going to pass the mountain. So here the height is great. So by the time it gets to the mountain, the height is above the mountain. So this is therefore, okay, therefore it passes the mountain. Okay, so let me just scroll this down so you can actually see. Okay, so this is our original problem. Break it up and then jump to your velocity. So basically, we're just trying to find out the maximum, the maximum height, the location of the maximum height. Well, I'm just going to scroll through this so that you can pause and look at it for yourself and try and understand it for yourself. Okay, hang on. So you can press pause at any time to convince yourself. Almost there. Okay, all right. I hope you understand it.